Hi everyone, today we are going to talk about 12.7 normal distribution part 2. So we are going to be able to find the intervals of data by using standard deviations and mean. So in the last lesson, we were talking about what is the normal distribution, and also I introduced what is empirical rule. So if anything, any data is distributed normally, then it has a bell curve like this. And we learned that in the center here, this is the mean. Also at the same time, median and mode occurs in the same point here in the middle, right? In the center. So mean, median, mode, the highest point is the most of number of the amount occur. So mean, median, mode. And then we learned that if you go add one standard deviation here and subtract one standard deviation within one standard deviation range from the mean, that's a 68%. Two standard deviation range is 95%, and three standard deviation range give you 99.7%. So almost most of the data is located spread between these three standard deviation range, right? So we learned how to find out each sector, how many percent of data is in there in each sector. This one, sector 1 has a 34%, by dividing 68% by 2, one standard deviation range. 34%, and then S3, how did you get it? From here to here, within the two standard deviation range is 95%. If you divide by 2, it's here, right, in this section, or this section, which is 47.5%. And then subtract the S1, right, or S2, doesn't matter. Then you will have S3 or S4, which is 13.5%. About how do you get S5, S6? Again, if you know that three standard deviation range is 99.7%. If you divide by 2, you will have a half of this, right? Half of this. So that will be, and after that you subtract 34% here, this one, and 13.5%, together 47.5%. If you subtract, you get the 2.35% of data is in here. So 2.35%, 13.5% here, and 34%. Here also 34% in this range, and here 13.5%, here 2.35%. Right? So if you have 1,000 students, how many students or how many data will be in the section 1? 340 students, right? 340, 34% of 1,000. So that way you can, calculate or count the number of data in any sector. So let's see with the example. In an all-boys school, the heights of the student body are normally distributed. So normal distribution we are using. Mean is 69 inches, and standard deviation is 3.5 inches. So using the empirical rule, which means 68% for one standard deviation range, 95% for two standard deviation range, and 99.7% for three standard deviation range, right? determine the interval of height that represent the middle 68% of male heights from this school. 68%, middle 68%. So 68%. So do you know how to calculate? So let's see with a diagram. That'll be easier. So when we draw a normal distribution curve, bell curve, this is the mean, right? Here's the mean. What is the mean? Mean is 69 in here. And then 68% is from here, one standard deviation range. So mean minus the standard deviation, mean plus standard deviation within this range, right? So we should get this interval, right? So how do you get it? Yes, 69 minus 3.5, the standard deviation is the lower bound. And 69 plus 3.5, which is 72.5, is right bound, higher bound. So your interval is 65.5 through 72.5. That's it. Everybody understand? So in this interval, you can see 68% of the students, right, are in this range, in this interval. 68% of students are in this interval. All right, let's have another example. So 1800 hours normally distributed with the mean is 1800 hours for live birth. Standard deviation 70 hours. So amount of life, the lifetime of live birth. So 1800 hours the mean, 70 hours of standard deviation. What is the interval for 95%? Middle 95%. So what should you do? From the mean, how many standard deviation range? Yes, 95%, 2 standard deviation. You know how to do it, right? So let's do like this. From 1800, from the mean, left bound or low bound, what do? You subtract 2 standard deviation. 2 times 70, you get the 1660. Upper bound or right bound is what? 1800 plus 2 standard deviation. So from here to here, right? So that will be 1940. And then this is the answer, 1660 through 1940. That will have 95% of live births. All right, that's it. Let's stop here.